Okay, sorry about that. I ran out of memory on my iPad. I had to go back and delete some stuff so that I could continue this video for you. Actually work through like more than half of that example before I realized it wasn't recording anymore. We're going to do this example forward and backwards. Let's suppose we've got a line that makes a 120 degree angle with the horizontal axis, and we want to find what slope that line has. So, for example, this line here makes about 120 degree. Let's suppose it has a y-intercept down here, maybe like 0, -2, and it makes about a 120 degree angle with the horizontal axis. So let's find the slope of this line, and then since we know the y-intercept, we'll just write the equation too. So I'm going to use my tangent function here on my calculator. Oops, there it is already for you. So I'm going to type in tangent by pushing the tangent button, put in my measure of 120 degrees, push enter, and out pops my slope of negative 1.732. So I get an m equals negative 1.732. That looks right for this line. Right, remember that negative slopes correspond to lines that decrease from left to right, right? So since this line is like a hill, it's like going downhill, it should have a negative slope. If it was going uphill, it would have a positive slope, like our last example. I should note, it's good to note that the angle that we're talking about with respect to the intersection is always the one that starts from the part of the x-axis that points right and continues until it hits the line. Because really you could think of this as like part of the angle of intersection too. So like, what part is this? We're looking for this part. Okay, this would be the supplement of 120. So this is a 60 degree angle. That's not the one we're interested in talking about. We're interested in talking about this 120 degree angle. So because this line has an intercept of -2, it looks like the equation for the line is negative 1.732x minus 2. So we get y equals negative 1.732x minus 2. I am going to, let's plot that line in our calculator just to check. So I'm going to do negative 1.732x minus 2. And then for my window, I'm going to change it to zoom square so that we get true angles. And it looks like my window's off. Sorry. Okay. So zoom square. There we go. And it looks like that line makes a 120 degree angle with the positive x-axis, which is pretty close to the picture that I drew there. So let's do the same thing the other direction. So suppose we know that the slope is negative 1.732. I'm interested in finding what is the measure of the angle. I'm just going to write the word degrees. So what degree measure does that correspond to? Now we already know that the answer is 120, so let's see if we can recover that answer. We're going to get something that's kind of weird, so that's why I kind of wanted to do this example first. Okay, so let's use the tangent inverse function. We're just going to plug in negative 1.732. So let's see. So I'm going to do tangent inverse. So you can see on my keyboard here, here's my tangent function. Tangent inverse is directly above that. So if I push second and then this button, it's going to use the tangent inverse function instead of the tangent function. So let's put the slope into the tangent inverse function and we'll get the degrees out. So The slope was negative 1.732, which is already here. So I'm actually just going to put in the, use the answer button. So here's tangent inverse. Push the second button, and then this button. I'm going to put in, actually I'll put in that value, negative 1.732, and press enter, and then we get something that's a little odd. We definitely don't get back 120, which is weird. So let's take a look back at that picture and see what this is telling us. So here's our line. I'm only going to draw the horizontal axis here so it's a nice simple picture. Here's our angle that we expected to get of 120 degrees, and then I just mentioned that the other angle that this makes is 60 degrees, because that's the supplement, right? 120 plus 60 gives us 180 degrees. So the way that tangent inverse works is if our slope is negative, it gives us the opposite of the supplement. It gives us this angle. Really what it's telling us is that instead of going up 120 degrees, we go down by 60 degrees. That's why it's negative. It means go down 60 degrees. All right, so in order to find the slope for negative, or the angle, excuse me, for negative slopes, we're always going to use the formula tangent inverse of the slope plus 180 degrees. Okay, so notice that when I do tangent inverse of the slope plus 180 degrees, pops out my 120. This is a little different than what we put in, but now that's just because I rounded to 3 decimal places instead of using all these values. Okay, so let's do one more example where my slope is positive, and another example where my slope is negative, and maybe one more interesting example. So, suppose that I have a slope, suppose that I have a slope of 2, and I want to find the angle that goes along with that. So I know that my slope is a positive 2, and I want to find the angle that that line makes with the positive axis. Like, for example, if I wanted to know the angle that the line y equals 2x minus 1 makes with the horizontal axis. This is the method that I would use to do that. So I'm going to use the tangent inverse function. Since my slope is positive, I don't need to use tangent inverse of m plus 180. Let's look at it. So let's do tangent inverse of 2. So I'm going to push the second button, then here's my tangent button, put in a 2, and I get 63 degrees. Okay, if we look at this picture, it looks like 63 degrees. So if you're using graph paper, if you were to graph that line that passes through -1 with your little boxes, and you were to go up 2 over 1, and then continue that line, and then use a protractor to measure this angle, you would find that it's really, really close. What you get is really, really close to 63 degrees. Okay, let's do one more example with a negative slope. Let's say the slope is -1/2. Like, for example, y equals -1/2 plus 3. So there's my x and y axis. y equals negative half. Plus 3 has a y-intercept of 3. I just kind of drew that slope out of scale, so I'm going to start over. More like that. Still not that great, but pretty good. So here's y equals negative 1/2 x plus 3. I'm interested in finding what is the measure of the angle with which this line intersects the horizontal axis. So my slope is negative 1/2. So since that is a negative number, I'm going to use tangent inverse of negative 1/2 plus 180, because remember it's going to give me the negative supplement. Does anybody see what I did wrong again? That's a positive slope, not a negative one. One more try. Alright, there we go. So that's about a slope of negative 1/2. Here's y equals negative 1/2 x plus 3. Sorry if you're taking notes in pen. I've told you not to do that before. So we're interested to know this angle that our line makes with the x-axis, okay, with the horizontal axis. So since the slope is negative, I'm going to use that tangent inverse of m plus 180. In this case, that's tangent inverse of negative 1/2 plus 180. So let's plug that in our calculator. Tangent inverse of negative 1/2 plus 180 is 153.43 degrees. So about 153 degrees. That's good enough for me. Alright, so as a summary, when our line is given by an equation y equals mx plus b, m is the slope, b is the y-intercept. Okay, the relationship between the angle that the slope makes, or excuse me, the angle that the line makes with the horizontal axis if that angle is theta, the relationship is that the slope is equal to tangent of theta, and if the slope is negative, then we'll use the reverse relationship that the inverse tangent of m plus 180, that gives theta. Or if m is positive, it's just tangent inverse of m. One more thing to mention, one more little bit of weirdness. This kind of has to do with slope. Remember that the slope of a horizontal line is 0, and the slope of a vertical line is undefined. Okay, that's because the change in x values for this particular slope is 0, and the change in y is some number. So if we tried to find the slope between these 2 points, for instance, we would get a 0 in the denominator, which is definitely not allowed. However, if we look at a vertical line is perpendicular to a horizontal line. So we know that vertical lines intersect the horizontal axis with 90 degrees, at an angle of 90 degrees. So the question is, what happens if I try to find the angle using tangent of 90? Let's plug it in and find out. Tangent of 90, bam. My calculator gives me an error. Okay, my calculator gives me an error because this number is not defined. It would be just like if I tried to do 1 divided by 0. Okay, my calculator gives me an error. So if you're trying to find the angle of, this should be an, if you're trying to find the slope of a line that makes a 90-degree angle with the horizontal axis, you can't. It doesn't have a slope. The slope is undefined. If I think about this, what angle does this make with the horizontal axis? You can think of it two ways. Either the angle is 180 degrees, it makes a 180 degree angle, or it makes a 0 degree angle. So the question is, what does tangent return in that case? If you use your calculator, you'll find out the tangent of 0 is 0, and the tangent of 180 is also 0. So it actually returns the right answer in both cases. The slope of this line is 0, and it returns the right answer here. The slope of this line is undefined. All right, so you've got some practice problems to work on. Enjoy.